Here goes 2007, number 3 on the AB test. It is not the same on the BC test, and this one is fun. All right, the functions f and g are differentiable for all real numbers. Okay, I'm going to go ahead and stop right there and tell you this. Because they are differentiable, that implies that they are continuous. If I can find the slope somewhere, then I know I have a continuity. Differentiability implies continuity. Continuity does not imply differentiability. When I say that, continuity does not imply differentiability, I'm thinking of like an absolute value. That vertex of an absolute value is continuous, but it's not differentiable. Okay? I'm saying that because that's going to come in handy. They slip in little subtle words like this that you need to glean from later. And that's a good word too, glean. And G is strictly increasing. Okay? The table above gives values of the functions. The first derivative is at selected values at x. The function h is given by that. Explain why there must be a value r between 1 and 3 such that h of r equals -5. What? Okay. This is saying something exists. Now prove that it exists. I want to prove that there is a value in between two other values. It is in between them, like an intermediate value. So I'm going to use the intermediate value theorem. So here goes. Number 3, part A. Explain why there must be a value r between 1 and 3 such that h of r is -5. When I first looked at this, I knew it was intermediate value theorem, and if you didn't think of that, that's fine. But here's the thing. You need to start figuring out some h values pretty quickly. So let me actually put the paper like this so you can see both things. So I need to figure out what h of 1 is. Well, why do I need to know that? Well, start experimenting. If you don't know you need to know that, then look here and then just start making up stuff. So I'm going to find f of g of 1 and then subtract 6. I also need to know what h of 3 is. F of g of 3, and then we subtract 6. And we do that. We're going to plug in a 1 into the g function. Plugging in 1 into g gives me a 2. So we have f of 2, not f of g of 2. Sorry. Forgot how to do composite functions for just a second there. F of 2 and then minus 6. F of 2 is 9, so 9 minus 6 gives me 3. You can do a lot in your head, but I don't want to leave too much out here and just kind of lose the process. So f of, well, g of 3, that would be 4, so f of 4 and then minus 6. -1 is going to give me -7. So basically what they're saying is, explain why there must be some x value between 1 and 3 such that h of x is -5. Okay, well, -5 is between these two. So let's do it. And let's just jump right in with an explanation using the intermediate value theorem, which we have practiced. So let's see. How can I word this? If I word it exactly like I did, it was a little clunky. I put because of the intermediate value theorem, but we'll go with that. May as well. I'll just say this. The intermediate value theorem. Intermediate. I'm spelling the whole thing out when you can really just put IVT. Intermediate value theorem states that, well, what does it tell me? Well, it tells me that something exists between two values if it's continuous, and what I'm looking for is between those two values. That was not very well worded. Let's try this again. The intermediate value theorem states that there is an r. I'm kind of repeating the question here. For 1 to r to 3. So r is between 1 and 3 such that h of r equals -5. Since, okay, well, what are the conditions that have to be met for the intermediate value theorem? Well, it has to be continuous. Since h of x is continuous, and I went a little overboard in my explanation when I did this one on my own and practiced it. And I said that I know it's continuous because f and g are differentiable. Because they're differentiable, it implies continuity. And then when I looked at the answer key, they left that out. So if you want to put that in, you could. So you can look at my scribble here. H is continuous as implied by the differentiability of f and g. That's perfectly fine. I've come to realize it was a little bit too much, but it's continuous. But I had to say that, and they had to say that so I'd know it was continuous. Okay? Since h is continuous, And, well, also I'm looking for something that is equal to -5, and -5 is between those two. So let's just say that h of 3 is less than or equal, well, less than -5, which is less than h of 1. And there we go. That's really it. And so when I look at the answer key, you get a point for finding out what h of 1 and h of 3 are. So there we go. Here's a point right there. And you also need, or you also get a point for that and all of that. Now, it doesn't have to be worded exactly like that, but no, let me switch colors here. And I know you need that, and I know you need that. And you need to say this word, or you need to say IVT. You do need to say, I know this because of the intermediate value theorem, and there are 2 or 3 conditions that have to be met. Some textbooks say 3, and I've taught it with 3. Nevertheless, here are the 2 big conditions. Continuity, and the y value you're looking for is between the 2 y values that you found. And so we know that it exists. The third condition was that these 2 are not equal, which is really implied kind of in the fact that it's between them. Okay, so that was part A. Let's do part B. And part B is also one of those things that's kind of like an existence theorem. So like, how do we know that something exists? Explain why there must be a value c, also an x value, between 1 and 3, such that h prime of c is equal to -5. Well, now we're dealing with a derivative, right? So this is an existence of the value of the slope. Okay, well, that sounds like the mean value theorem to me. Maybe it didn't sound like that to you, but it just pays to be very familiar with these theorems. So I know that a value exists, intermediate value theorem. I know that a slope exists on an interval, that's mean value. So a value exists of a regular function, intermediate value. A value exists of a derivative on an interval, that's mean value. It's wordy, but that's what it is. So here it goes. What do I need for the mean value theorem? Well, for one thing, I need to know what the slope is. So let's find the slope between 1 and 3 of my h function. So I'm going to find h of 3 minus h of 1 over 3 minus 1. This is basically the average value. It's an average value, mean value, same idea, right? So I already figured out what those are. That's -7, then -3 over 2, so -5, right? Okay, so the slope between 1 and 3 is -5, right? So let's just jump right in here. The mean value theorem states that if h is differentiable. Okay, now I'm going to pause right here. On the answer key, they said continuous and differentiable, and on mine, I just put differentiable. Differentiability implies continuity. I personally feel like that is sufficient, but I'm going to go a little further and be super meticulous with what they put. If I can tell you it's differentiable, then I know it's continuous, but they put both on their answer key, so maybe you just could be thorough, which is what I did originally up here when I put, you know, it's implied by the differentiability of f and g, whatever. Being thorough does not hurt. Is differentiable and continuous, then there exists a C. I'm kind of copying the problem here in the way it's worded, for C between 1 and 3, such that h prime of C equals -5. And I found that because I found that. And there we go. So that's really it. And so there's 2 points for this one. They wanted you to say, hey, I found that value. There's 1 point there. And then all that is another point. And when they say using the mean value theorem, and let me show you exactly what they said. Conclusion using the MVT. They probably wanted you to say MVT. And they wanted you to say, I'm going to say differentiable for sure. I'm going to underline continuous also. And this is also an important part of it, that you're just kind of like wording the rest of it, that you know that it exists, which kind of is implied by that statement up there. Okay, let's get to part C. And part C says that W is given by this function. And then they said, find W prime of 3. So I'm going to skip a line for reasons that will become obvious in a minute. I want to find W prime of 3. Okay, well, if I want the derivative of an integral, then they undo each other. So let's do that. I've written that down. So now, before I find out what happens at 3, let's ignore what happens at 3. Let's just figure out what happens if I take a derivative. There's that. So the derivative, they undo each other. However, this g is going to go right in there. So I'm going to have f of g of x. Okay, great. And we're done. No, we're not. Because g is a function, I need to, it's chain rule, I need to multiply by the derivative of that inner part. So I'm going to multiply by g prime. Now, you might be looking at this saying, what about your c value? And what about the 1? And it all goes away. It all works out, and we've been through this, but basically if you were to somehow be able to do this by hand, and you really can't because we don't have the actual functions, then that would vanish because you'd be taking the derivative of a constant, right? All right, so now let's find out what W prime of 3 is, and this is where things get pretty easy. F of g of 3 times g prime of 3, and now we just look at the table of values and we go from there. So I need f of, well, g of 3, and I'm looking at the table, and you can't see where I'm looking, but you've got a table too. And then g prime of 3 is 2, f of 4 is -1, -1 times 2 is, I wrote way too much, but it's -2, and we got it. So they were looking for two things on this one. They looked for that, and they looked right here for the chain rule. They wanted to make sure that you did the chain rule. Okay, let's do part D. Part D is tricky. Part D is one of them that involves so many different aspects of what you've learned, it blends them all together. And that's what they're testing you on. Do you know how to find a tangent line? Do you know how to find the slope at a point on an inverse of a function? Can you use a table? You know, those kinds of things. So here goes. If g inverse is the inverse function of g, write an equation for the line tangent to the graph of y equals g inverse at x equals 2. Whoa, way too much going on here. That's okay. And when I read it, I knew what I had to do and I knew what it involved, but I had to kind of take it in pieces, and I went very slowly. And it's easy to be overwhelmed with these, so let's go kind of slowly. I have an inverse, but what are they telling me to do? Write the equation of a line that's tangent. So then when I made my answer key, before I looked at the answer key, I wrote this because they said, write the equation of a line tangent. Good. Okay, now let's find what I need. Now that I know what they're asking, let's look for what I know and find what I don't know, and I do know this much. So the next line says this, y minus something equals m, and then x minus 2. Great, we've made progress. So what am I missing? I'm missing this, I'm missing this, and now we'll figure out those things. So they said that g inverse is the inverse of g. So I want to know the y value that corresponds with an x value of 2 for my inverse function. So basically, let's go ahead and look at what I'm missing. I'm missing the m. That's going to be the tricky part. And I'm missing the y. So let's go ahead and find the y. Tell me why. I need to know what g inverse of 2 is, and this goes back to some stuff that we've done. I don't know what it is, and because g inverse is not in my table, but it sort of is actually, because these are the same value right here. So I need my g to give me an output of 2. So my g gives me, that's an input, not an output. My g gives me an output of 2 when x equals 3. Okay? No, I accidentally just lied to you. My g gives me an output of 2 at 1. Yes, sorry. Woo, man, I just confused you. That is not the... I pointed, I was like, no, that's the input. That's the output. Wow, it's easy to get confused on these things. I had it right on my answer key when I did it earlier, and then I started second guessing myself. Here goes. Here's my input. Here's my output. I'm sorry I just wasted 30 seconds of your life. I'm not going to film this video again because of that, though. Input output of 2. So when I get an output of 2, my input was 1. Okay, whew, sorry about that. Yay. Now we don't know the slope. It looks like the sign for perpendicular. I didn't intend it to look like that. I need to know the slope, derivative, of my inverse at 2. Well, that is a formula that you should know, and you need to have it in your back pocket, metaphorically, not necessarily literally. And it is now originally it looked like this. When we would do it, we'd be like, well, if f and g are inverses, so like you don't have to write this, but if I had this, then I would say that the slope was f prime of g inverse of x, and I would do that. And so we're used to having an f there because we're like, oh, f and g are inverses. Well, in this case, g and g inverse are inverses, so this is going to be g prime, okay? So g prime, g inverse of 2. Now let's work our way out of this thing. I'm about to find the slope. It's going to go right there. 1 over g prime of, well, g inverse of 2. Lucky me, I know it. Excuse me. And now I need to know what g prime of 1 is. G prime of 1 is 5. So I found my slope, and it was 1/5. And so there we go. We found it. And you can leave it like that. I mean, you don't have to solve that. You can leave it like that. So let's talk about what they were looking for. They wanted to know that you knew that. They wanted you to get that 1 right there. They wanted you to get that 1/5, and then they wanted the equation of the tangent line, which we have found all of them. I know this one took longer than 15 minutes, but it took a while to explain and kind of think our way through it. However, the more you know these theorems, the faster you'll be. And you'll be able to knock these out much quicker if you can look at a problem and say, they're asking for, let's go back here, they're asking for something in between two values, intermediate value theorem. They're asking for a slope on an interval, mean value theorem. Oh, I'm going to have to take the derivative of an integral. I better do that and use the chain rule, and you go fast with it. Identify the parts that they're asking. What's the biggest thing they're asking? Equation of a line tangent. Fill in the pieces you don't know from there.